In this function, in this video, I wanted to talk through an introduction to the exponential functions, specifically our basic exponential functions of the form f of x equals b to the x. Now, first thing with these functions, we had some restrictions. You might have noticed in the notes when we first set this up that b must be strictly greater than 0 and not equal to 1. And I wanted to give a brief discussion of why we have those restrictions. So first of all, if the base were 1, then our function would have the form 1 to the x, which in that function, no matter what you input for x, the output will always be 1. And so this is a constant function. It doesn't exhibit the kind of behavior that we generalize for exponential functions. So this is kind of its own separate case when the base is 1, and so we exclude that when we talk about exponential functions. Now, if the base were a negative number, let's say -4, what kind of a problem do we run into then? So if the base is -4, then this function would look like this, -4 raised to the x. If we start substituting some x values, let's see, so f of 2 would be -4 squared, which would be 16. There's no problem there. But if we try to evaluate something like f of 1/2, then that's equal to the square root of -4, right? Because the 1/2 power can always be written as the square root. And this is equal to the imaginary number 2i, which when we talk about domain of a function, we mean the set of x values that we can input and get a real number out. So this result here tells us that 1/2 does not belong in the domain of this function, but 1/3 would. You can raise -4 to the 1/3 power in your calculator. You get a real number. It's a negative number. It's a long, ugly decimal, but it's real. So 1/2 would not be in the domain, but 1/3 would be in the domain. But 1/4, another even root of a negative number, that's going to be imaginary. So 1/4 would not be in the domain. And so you run into all these issues with domain that gets overly complicated. So we just say, okay, the base needs to be strictly greater than 0. When that is true, the domain for these functions will always be all real numbers. You take a positive base, raise it to any number, any exponent, and you get a real number. So once we make those restrictions, the domain for any function of this form will be -infinity to infinity. Now, as far as the graphs go, I want to talk about that on the next page. There's a couple of generalizations we can make about the graphs of functions of this form. Excuse me. So first of all, if we input 0, for a function of the form f of x equals b to the x, if we evaluate f of 0, that would be b to the 0 power, and b is some positive number we can assume. So this is always equal to 1. Anything to the 0 power is defined to be 1. So the graph of f of x equals b to the x will always include, I'm going to refer to them as the key points for functions of the graphs of functions of this form. It's always going to include the point 0, 1. Whenever you input 0 for your x, you're going to get 1 for your output for your y. Now, there's also something we can generalize for f of 1. So f of 1 will be b to the first, so that will always give us the base b. So whenever 1 is the input, the output will be the base b. So any function b to the x, they all go through this point 0, 1. Now that second point, the 1b, that depends on the base. So now let me go to a specific example. Let's say I want to graph y equals 2 to the x. So that would also go through the point 1, 2. They also all have a horizontal asymptote at y equals 0. The reason for that, if we think through what happens with, let's say, 2 to the x, let's stick with that specific example, when you plug in some negative values for x. So if x is -1, then your y value is 2 to the -1, which is 1/2. If x is -2, then the y value is 2 to the -2, so that's 1/2 squared, that's 1/4. if x is -3, then the y value is 2 to the -3. That's 1 over 2 cubed, which is 1 over 8. And so if I try to plot those points, which it's not going to be so easy on my tablet, but 1/2, and then 1/4, and then 1/8. 2 to the -4 is going to be 1/16. You're going to get these smaller and smaller fractions. It's going to get closer and closer to 0, but never quite touch it. So you've got this horizontal asymptote at 0. No matter what you try, as negative as you want to get for x, 2 raised to this big negative number is going to be a tiny fraction close to 0, but it's never going to quite get to 0. Okay, and the graph continues upward this way. I don't want to plot too many points. I don't want this video to be too long with just a lot of point plotting. So what I wanted to drive home are the key points that all of these graphs have in common, and then the basic shape of the graph, which is something like what I've drawn in blue there. Now, one last thing I want to include. You get something slightly different. So you get this basic shape that I've drawn in blue when the base is bigger than 1. You get something slightly different when the base is between 0 and 1. So let's say specifically the base is 1/2. So y is 1/2 to the x. This is acceptable. You can't have a base of 1/2. That's not equal to 1, and it's strictly greater than 0. And so this 1/2 to the x will still include the point 0, 1. And it'll also include the point 1, comma, the base, which is 1/2. So it's going to go this way. And then if you think about it, 1/2 squared, that's 1/4. 1/2 cubed is 1/8. So it's going to be getting closer and closer to 0. It's still going to have that horizontal asymptote at 0, but it's going to approach it on the right side this time. And it's going to increase this way to the left. And so you get this shape in red when the base is between 0 and 1. And so those are the main things that I wanted to inform you of about the graph of b to the x right now, is they all go through the point 0, 1, 1b, horizontal asymptote y equals 0. So you can graph those three key features right away. Horizontal asymptote here, 0, 1, and then 1, whatever the base is. That'll give you 2 points on the graph, and then the asymptote. And then that the basic shape looks like this. It's got an increasing shape when the base is greater than 1. It's got a decreasing shape when the base is a fraction between 0 and 1.